let us discuss about this Cantor intersection theorem, or we may say we would like to introduce Cantor set. We have first drawn with the green ink the interval 0 to 1, and then we have equally divided in three parts. So this is 0, this is 1/3, this is 2/3, and this is 1, 3 by 3. And we remove this middle third from. So 0, 1 was the initial interval from which we removed the open interval 1/3, and after removing this we have these two closed intervals. Okay. In the next stage, I2, we prefer to remove the middle third of this 0 to 1, 1 by 3. So obviously this is 1 by 9, this is 2 by 9, and this is actually 3 by 9. And we remove the middle third, which is nothing but 1 by 9, 2 by 9. And we also remove the middle third of the other closed interval. So this is 2 by 3 means 6 by 9, so this is 7 by 9, and this is 8 by 9, and we remove the portion 7 by 9 to 8 by 9. This is the open set, and we remove it from I2. Sorry, we remove this from I1, and we get I2. So what is I2? I2 is nothing but 0, 1 by 9, 2 by 9, 1/3, this we may think about 3 by 9, union 2/3, 7 by 9, which we may think of 6 by 9 and 7 by 9, and then we have union 8 by 9, 1, which we may think of 9 by 9. And then obviously we remove from I2 the middle third of this portion, which is obviously 1 by 27 and 2 by 27. Then we have the middle third of this portion also, which I request the viewer to calculate. Remember, this is 3 by 27. So obviously you will be able to calculate this. This is 9 by 27, isn't it so? So this is obviously 6 by 27. And similarly we have removed the middle third of this and this also to reach I3 when we remove from I2 this middle thirds. Just note that whenever I have first removed the middle third from 1/3 to 2/3, it has length 1 by 3. It has length 1 by 3. And then we have removed these two. And if we add the length of them, it will become 2 by 9. And then if we add this 4 part, it will be 4 by 27, because each one is of 1 by 27. And this will go on. If we repeat this procedure, interestingly, if we add them up, the portions removed from this interval 0, 1, it will add up to 1. It is very easy to calculate, because if you take 1/3 common from this sum, it will be of GP series. of the proportion 2 by 3 which is less than 1. So it will be a by 1 minus r, or 1/3 by 1 minus 2/3, which is 1. So this Cantor set, which is developed by removing the open intervals of the middle thirds gradually, step by step, gives a very rich structure and shows that the interval 0, 1 contains uncountable numbers and is equivalent to all the interval from minus infinity to plus infinity, or rather 0 to plus infinity. I would also like to request the viewer to think about the fact that what are the values lying within this interval, or within this line from 0 to 1, which are included in this Cantor set, which is the intersection of these removed portions. Remember that I1 is the intersection of the removed parts. What is I1? I1 is I minus, I is actually 0, 1, and we remove this part. So I1 is actually 0, 1 is not I1, 0, 1 is not I1. I would like to write I is 0, 1, and we removed from it this open set. So it is we may write it as I1, I is this, and then we have I2, which is 0, 1 by 9, then union 2 by 9 to 1/3, and so on. And if we take the intersection of this Ik, or rather In, which are this type of I1, I2, I3, then what are the points we have? This is a very rich structure. I just give a basic idea of this.